For the first time in history, a spacecraft has dared to touch the Sun. NASA's Parker Solar Probe has ventured closer to this fiery giant than we ever imagined. And this achievement will be remembered in history. Because no metal or even diamond could withstand such extreme heat. But here's the big question. How does the Parker Solar Probe survive in this searing heat, reaching thousands of degrees Fahrenheit? Let's rewind a bit. Back in the early 1900s, scientists made a strange discovery while studying the Sun. They noticed something odd about the wavelength and colour of the Sun's light. These two factors could give us a clue about the Sun's temperature. They figured this out with the help of a spectrograph, even while sitting right here on Earth. Now here's where it gets interesting. There's a direct connection between the colour and wavelength of light and the temperature of the Sun. The result they found, though, led to a mystery that still hasn't been solved. What they discovered was that the surface temperature of the Sun, its outer layer, was around 5,500 degrees Celsius. But the outer atmosphere, called the corona, was millions of degrees hotter, somewhere between 1 to 3 million degrees Celsius. That's like moving away from a fire, only to feel the heat increase. It's a crazy phenomenon, one that scientists have been trying to figure out for over 100 years. Normally, this outer layer is hidden by the Sun's light, so you can only see it during a solar eclipse, or with special equipment like a coronagraph. But after NASA's formation in 1958, many space missions took off, and several spacecraft started their journey into space. Yet to really crack this mystery, they needed something that could get close enough to study the corona firsthand. But getting that close to the Sun? Not so easy. The Sun's heat is so intense that metals like iron, which melts at 1,500 degrees Celsius, or the toughest metal, tungsten, which melts at 3,422 degrees Celsius, would melt instantly. Now imagine the situation at the corona, where the temperature reaches millions of degrees Celsius. What do you think would happen to these metals there? But that's not all. There's another huge challenge. Getting close to the Sun is extremely hard because of its massive gravity. When a satellite needs to return to Earth, it has to slow down so that Earth's gravity can pull it back. But if a spacecraft is leaving Earth's orbit to go to another planet, it has to speed up. For instance, to send a spacecraft to Mars, you first launch it from Earth's orbit, then adjust its speed and angle to move it to Mars. Now, Earth and the Sun are 150 million kilometers apart, and to send a spacecraft into the Sun's orbit, we'd need much more energy than we've ever had before. So NASA's experts came up with a brilliant plan. Send it to Venus first. Venus is our second planet, and its gravity helps speed up the Parker Solar Probe, launching it towards the Sun. The spacecraft had to complete 24 orbits around Venus to gain enough speed. On August 12, 2018, Parker Solar Probe was launched from the Cape Canaveral Air Force Station. Over the next 8 years, it would use Venus's gravity to accelerate and eventually reach the Sun. The spacecraft will make 24 passes around Venus before reaching the Sun. Each orbit gives the spacecraft 37 hours to collect valuable data, and over 8 years, it will spend 900 hours studying the Sun. Then, on April 28, 2021, NASA confirmed that the Parker Solar Probe had successfully entered the Sun's corona. The mystery of the corona's heat, reaching 1 to 3 million degrees Celsius, was now officially confirmed. But why is the corona hotter? What's the force behind it? That's still under research, but Parker Solar Probe is investigating it right now. Now you're probably thinking, how does the Parker Solar Probe survive all that heat? The answer is pretty cool. It has a heat shield, but not just any ordinary shield. This shield is made of carbon, specifically designed to absorb the Sun's heat. Inside, it's 97% empty, making it even more effective at protecting the spacecraft. On top of that, it's coated with graphite and resin for extra strength. The probe can handle temperatures of up to 2,500 degrees Celsius. But since the Sun's corona is a mind-blowing 3 million degrees Celsius, how does it not burn up? This is actually pretty easy to understand. According to the law of thermodynamics, heat needs a medium to transfer. For example, during summers on Earth, air particles carry heat, which is why we feel warm even at night. If there are fewer particles, heat won't travel as easily. It's like putting your hand in boiling water. It'll burn immediately. But if you quickly put your hand inside a 300°C oven and pull it out, you might not even feel it. This is possible because water molecules make direct contact with your skin, while in an oven, nothing directly touches you. Experts say that the heat shield of the probe faces temperatures of 1,200°C, while the rest of the spacecraft stays much cooler. On the backside, where the sun's light doesn't reach, the temperature can even drop to minus temperatures. So even though the Parker Solar Probe is closer than any spacecraft has ever been to the sun, it doesn't melt because of its advanced heat shield and clever design. Pretty incredible, right? If you think this is mind-blowing, don't forget to like, share, and subscribe. Drop your thoughts in the comments. What do you think about this historic mission? Thanks for watching, and I'll see you in the next video.